Welcome back, friends. So in this lecture I am going to talk about how to calculate the formal charge of some atom, which is basically some constituent of some molecules or some ions. So before start of my lecture, it is very important to understand why should we calculate the formal charge of any atom in a molecule. So the formal charge of any atom in a molecule decide the way in which that molecule or that ion will participate in any chemical reaction. So to understand the reaction mechanism, it is very important to know about the formal charge of each of the atom which form that molecule or that atom. So here in this lecture I will briefly go through or briefly make you understood about some of the very simple tricks that you can use to calculate the formal charge, and that tricks is very easy, so that I will just discuss in this lecture, and also I will give some examples of different molecules or ions where I have calculated the formal charge of different atoms. So before start of my lecture, I just want you all to please subscribe to my channel Chembiosis, where you will get these types of lecture daily. So just let's start that lecture. Now there are basically 3 steps by which you can easily calculate the formal charge of any atom. So first of all, you have to actually draw the proper Lewis structure of that molecule or of that ion. So that portion, if you do not know how to calculate, how to draw the Lewis structure of that molecule or of that ion, you can ask me through the comment section. If you want to want some separate lecture on it, I will demonstrate it for sure. So after drawing the proper Lewis structure of that molecule or that ion, then you have to calculate the number of valence electron in neutral state. So suppose there is a molecule, a atom is present in that molecule. So first of all, you have to calculate the number of valence electron present when that atom will be in the neutral state. So that is the step 1. What is the step 2? In step 2, you have to assign half of the shared electron. So suppose A and B form some kinds of covalent bond, and suppose 2 electrons are engaged to form that covalent bond. So in that case, you have to assign 1 electron to atom A and 1 electron to atom B. So there will be the sharing of the bonding electrons in between the 2 participating atom. Okay, so this is the second step. Now what is the third step? So there can be some kinds of unshared electron which do not participate in any chemical bonding. So in that case, you have to assign full unshared electron. So if A atom has 2 unshared electron, you have to assign those 2 unshared electron. Okay, so after calculating or after knowing all these things, the first thing is the number of valence electron, the second is that number of shared electron, and the third thing is the number of unshared electron. You have to fit all those numbers into this formula. That is the formula for calculating the formal charge, which is basically the number of valence electron that you have calculated in step 1, then half of the number of shared electrons that you have calculated in step 2, and finally then minus the number of unshared electron, so that you have calculated in step 3. So this is the whole formula to calculate the formal charge of any atom in a molecule or in an ion. Now you can replace this formula with some shorter version, that is F is equal to Z minus half into S minus U. So F is basically the short form of formal charge. Similarly, Z is the short form of the number of valence electron, S is the short form of the number of shared electron, and similarly U is number of unshared electron. So now if you suppose if there are total 3 atoms, constituent atom in a molecule. If you calculate the formal charge of the individual atoms, then if you just take the sum of those individual formal charge, then the arithmetic sum of all the formal charge is the overall charge of the molecule. So this is the basic theory or basic formula to calculate the formal charge of any atom in a molecule or ion. So in the next slide I will give you some examples so that you can understand very easily how you can calculate the formal charge. Okay, so suppose we have to calculate the formal charge of ammonium. So suppose that we know that this ammonium has a positive charge. So there can be, the ammonium can be present in different types of salt, like it can be ammonium hydroxide or ammonium nitrate. So in that case, that the cationic counterpart is called the ammonium. Basically it has some single positive charge. Now suppose we do not know that how much charge this whole ion possesses. So we have to calculate the formal charge of each of the constituent atom, and also we have to calculate the overall charge of the molecule. So how do we calculate them? So first of all, we have to draw the proper Lewis structure of this ammonium. So you can see this is the nitrogen atom. So it will form 4 bonds with 4 hydrogen. Okay, so this is the proper Lewis structure of the ammonium ion. Now you can see that these all hydrogens are all equivalent. So if we calculate formal charge for any one of these hydrogen, it will be same for all other 3. Okay, so first of all we should concentrate how to calculate the formal charge of any one of the hydrogen atom. So you can see that the for formal charge, for calculation of the formal charge, we have to know the number of valence electron. Okay, so for hydrogen the number of valence electron is always equal to 1, because it is a group 1 element. So in case of hydrogen, you know that there is only 1 electron at the orbit, and in the nucleus there is only 1 proton. So Z is equal to 1 for hydrogen. So the number of valence electron for hydrogen is 1. Then we have to calculate number of bonding electrons. Okay, so you can see that in case of hydrogen it forms covalent bond with the nitrogen, and the number of bonding electron is 1 plus 1, that is equal to 2. So we have discussed in the previous slide that we have to take half, we have to assign half of this bonding electron. So here you can see, as the number of bonding electron is 2, so we have to assign the share of the bonding electron will be half into 2, that is equal to 1. And as you can see, in case of hydrogen there is no unshared electron, so the third part will not be there. So the first part is the number of valence electron, the second part is the number of the shared electron. Okay, so you can see that the formal charge of hydrogen using the formula is 1 minus 1, that is equal to 0. So from this formula you can see that all hydrogen atom possess 0 formal charge. So there is no charge on any of the hydrogen atoms. Okay, now we will see how you can calculate the formal charge for nitrogen atom. So similar formula we will apply, that is formal charge is equal to number of valence electron minus half of the number of shared electron minus unshared electron. So same formula we will use. So for nitrogen the number of valence electron is 5, as nitrogen is basically a group 5 elements. Okay, and as you can see that in nitrogen form 4 nitrogen hydrogen bond. So in each bond the number of participating electron is 2. So total number of bonding electron is 8, and we have to take half of the 8. So the number of shared electron is half into 4 into 2, 8. So, and there is no unshared electron, so that's why the third part will not be there. So the formal charge of nitrogen is equal to 5 minus 4 is equal to plus 1. So you can see that the how we can calculate the overall charge of the molecule. As you can see that the formal charge on nitrogen is +1 and formal charge on all 4 hydrogen atom is 0. So the overall charge on the molecule is 1 plus 0 plus 0 plus 0 plus 0, that is equal to +1. So this is the way that we can calculate the formal charge of any molecules or any ions. So now let's go back to another example. So this is the example where we have to calculate the formal charge of nitrate anion. So this nitrate anion is basically a counter anionic part which is present in different types of molecule, like in HNO3 or sodium nitrate. So all this case the counter anionic part is the nitrate ion. Okay, so you can see this is the proper Lewis structure of the nitrate ion. So as you can see that for drawing the proper Lewis structure, the one of the very important thing that you have to see that whether the octet is filled or octet rule is satisfied or not. So you can see that by using this Lewis structure, the octet rule is very much satisfied. Now you can see that oxygen 1, these two oxygen 1 and oxygen 2 are similar. So whatever the formal charge we will calculate for one of this oxygen will be same for the second also. Okay, so for oxygen 1 and oxygen 2, at first we will try to calculate the formal charge. So you can see at first you have to calculate the number of valence shell electron present in oxygen atom. So in neutral state, obviously when the oxygen atom is in the neutral state, then we have to calculate the number of valence electrons. So as you know that oxygen is group 6 element, so it has total 6 number of valence electron in neutral state, and you can see that in both cases the bonding electron is 2, so it will, the sharing will be half into 2, that is equal to 1. And you can see there are total 6 number of unshared or unpaired electron, so you have to subtract it also. So the final equation for formal charge is 6 minus half into 2 minus 6, that is 6 minus 1 minus 6, that is equal to -1. So as you can see that each of these two oxygen content -1 charge. So this oxygen content -1 charge and this oxygen content -1 charge. Now let's take what is the formal charge of the third oxygen. So in case of the third oxygen, the number of valence electron will remain always same for an element. So this is equal to 6, and as you can see there are total 4 number of bonding electrons, so the sharing will be 4 by 2, that is equal to 2, and you can see the number of unshared electron is equal to 4. So the final equation for the formal charge for oxygen 3 is equal to 6 minus half into 4 minus 4, that is 6 minus 2 minus 4, that is equal to 0. So this oxygen is basically neutral one, it does not contain any formal charge. Now let's look about the central atom, that is the nitrogen atom. So we have to see what happened in case of nitrogen atom. So as you know, the nitrogen is group 5 element. Okay, so it will contain total 5 number of valence electron, and we have to calculate the number of bonding electrons is 1 2 3 4 5 6 7 8. So there are total 8 number of bonding electrons, and there is no unpaired electron. So the formula is number of valence electron minus half into number of bonding electrons, and as there is no unshared electron, so third portion will not come. Okay, so that is equal to 5 minus 4, that is equal to +1. So the central nitrogen atom contain +1. Now as I have told you, if you want to calculate the total charge on the whole atom or whole molecule, you have to take the summation of the all individual formal charge. So what will be the individual formal charge? That is -1 and -1, then for this +1. So the total charge is equal to -1. So this is the total charge on this ion. Okay. Now let's take some example of another molecule, that is called the water molecule. as you can see, in case of water molecule, the central oxygen is bonded with two hydrogen atom. So you can see that these two hydrogen atom are similar. So the formal charge of this hydrogen atom will be exactly equal to the formal charge of this hydrogen atom. So at first we will calculate the formal charge of this hydrogen atom. So the number of valence electron when the hydrogen is neutral state is equal to 1, and as you can see that the number of bonding electron is 2, so we have to take minus of half into 2, that is equal to 1 minus 1 is equal to 0. So both of these hydrogen atom contain 0 formal charge. Similarly, we have to calculate the formal charge for the central oxygen atom. So oxygen, as we have discussed earlier, that it is group 6 element, so the number of valence electron will be exactly equal to its group number, so that is equal to 6, then minus half of the number of bonding electron, so that is 1 plus 1 plus 1 plus 1 plus 1, that is equal to plus 4, and the minus number of total number of unshared electron, that is 1 2 3 4. So the formal charge for oxygen is 6 minus 2 minus 4, that is equal to 0. So all the atoms in water molecule contain 0 formal charge. So if you just do the summation, then the total charge on the molecule will also be 0. So it is totally a neutral molecule, and the atom is also, each atom also do not contain any formal charge. Now take the example of another neutral molecule, that is the ammonia. So this is the structure of the ammonia, where each hydrogen atom is covalently bonded with the central nitrogen atom. So as you can see that each each hydrogen atom are equivalent. So if we calculate the formal charge of any one of this hydrogen atom, it will be same for the other two also. So same, by using the same formula, or as we have done in case of water molecule, the formal charge of hydrogen is equal to 0. So that is understood. So each hydrogen atom contains 0 formal charge. Now what about the central nitrogen atom? So as I have told you that nitrogen is a group 5 element, so the number of valence electron will be equal to 5. Then as you can see that there are total 1 2 3 4 5 6 number of bonding electrons. So we have to assign the number of bonding electron, that is equal to half into 6. So this is the second part, and third part you can see that it contains 2 unshared electrons. So we have to fully assign these 2 electron, so minus 2. Okay, so the final formal charge is 5 minus 3 minus 2, that is equal to 0. So the central nitrogen atom also contains 0 formal charge. So the total charge on the molecule will also be 0. So this is another example. Now after showing you all this example, here I am just giving you some homework to calculate the formal charge of these ions. As you can see, this is methoxide ion, as you can see, and this is amide ion, this is cyanide ion. So all these ions are there, anions are there. So you have to calculate the formal charge of each of them. So I have just shown you the solution of the problem number C, that is for cyanide ion. So this is the Lewis structure of the cyanide ion. So the carbon and nitrogen are bonded with some kinds of triple bond, as you can see. So first of all we will try to see the formal charge on carbon atom. So as you can see that to complete the Lewis structure, the octet should be filled. So we can see that the number of bonding electron is 6 and the number of unshared electron is 2. So the total octet for carbon is being completed. Similarly, the total octet for the nitrogen atom is also completed. So it is a proper Lewis structure. So that thing we have to confirm. If we draw some wrong Lewis structure, then whatever the formal charge we will get will be totally wrong. So the first step of calculating the right formal charge is to draw the proper Lewis structure. Okay, so after drawing the proper Lewis structure of the cyanide ion, we have to determine the formal charge for carbon. So for carbon, as it is a group 4 element, so the number of valence electron will be equal to 4 for carbon, and you can see that there are total 6 bonding electrons, so we have to assign half into that 6 number. And as you can see, there are 2 unshared electrons, so we have to assign the full 2 unshared electron, that is -2. So for carbon, the formal charge is 4 minus 3 minus 2, that is equal to -1. Okay, and in case of nitrogen, nitrogen is group 5 element, so the number of valence electron is equal to 5 and the number of bonding electrons is 6, so we have to assign half into 6. And similarly, like carbon, it has 2 unshared electrons, so we have to fully assign this 2 unshared electron, that is 2. So the formal charge for nitrogen atom is 5 minus 3 minus 2 is 0. So as you can see that in case of cyanide anion, the formal charge of carbon is -1 and the formal charge for nitrogen is equal to 0. So if we just add up these two numbers, you will get the total charge on the molecule, that is equal to -1. So that's why we write the cyanide minus. So this is the total charge on the molecule, which is basically situated on carbon atom. Okay, so this is one of the solution of these 6 problems. So if you have any doubts in solving the other 5 problems, you can ask me through the comment section, then I will take some separate lecture to solve all those other remaining 5 problems. Okay, so there are some basic tricks to calculate the formal charges. You do not need to always calculate the number of valence electron, number of bonding electrons, number of unshared electrons. You do not have to go through all those rigorous process all the time. There are some very simple tricks by using, you can if you use those simple tricks, you can calculate the formal charge of any atom by just seeing them. So the first trick is that if you see any oxygen atom in this types of configuration, where it is only single bonded with some kinds of atom, then you can be sure that the formal charge of that oxygen will be none other than -1 if there is only single bond. Okay, similarly, if there is any oxygen which is a double bonded, the double bond can be on this types of double bond or this types of double bond. So in that case, you can be assured that you do not have to calculate the formal charge for oxygen. You can directly jump into the conclusion that the formal charge of these types of oxygen will be equal to 0. Similarly, if you find some nitrogen atom which has 4 bonding, you can see these types of 4 bonding is there, then the formal charge of the nitrogen atom will always be equal to +1. And in the same way, if you find these types of nitrogen atom where it is bonded with 3 atoms like this, in that case the nitrogen atom will always be neutral one, so the formal charge on nitrogen atom is equal to 0. So there are some other examples which is also shown in this table, as you can see, which shows some of the very simple formula by which you can calculate the formal charge by seeing this atom only. So you can see that if you see these types of configuration for boron, the formal charge will always be equal to 0. So if carbon is bonded with 4 atoms like this, or like this, or like this, or like this, the formal charge on carbon will always be equal to 0. So similar thing, if we see bonding of nitrogen like this, the formal charge on nitrogen will always be 0. Similarly, if you see bonding of oxygen like this, the formal charge will always be 0. So, and in case of -1, you can see if you see the carbon is bonded with only 3 atoms like this, or like this, or like this, the formal charge of carbon will always be equal to 1. You do not have to do all the calculation or all the things. You can directly jump into the conclusion that the formal charge of carbon will be -1. So these are some of the tricks by which you can save your valuable time during any problem solving. So this table, if you can look into the table, that will help you to understand why the formal charge are like this, and you can use it in to save all of your time. So that's it from this part of this lecture. If you have any doubt regarding this lecture, you can ask me through the comment section, and please do subscribe to my channel Chembasis, and take care of yourselves. Bye.